Let's tackle LeetCode 208, implement Trie, also called a prefix tree. You need to build a data structure that stores words and supports 3 operations. Insert a word, search for an exact word, and check if any word starts with a given prefix. If you insert apple, then search apple returns true. Search app returns false because app was never inserted, but starts with app returns true because apple begins with app. The naive approach is storing words in a list. Insert is fast, but search and starts with both scan every word. Too slow for thousands of queries. Here's the trick. Words share prefixes. Cat, car, and card all start with CA. Instead of storing each word separately, we build a tree where shared prefixes share the same path. Each node has up to 26 children, 1 per lowercase letter. To mark where a complete word ends, each node carries a Boolean flag called isEnd. Insert walks down character by character, creating nodes as needed, then marks as end on the last node so we know a word finishes there. Search walks the same path and checks the final node has is end true. Starts with just walks the path without checking the flag, because all we care about is whether the prefix exists. Each operation takes big O of M, where M is the word length. Let me walk through an example. We start with an empty trie, just a root node. Insert cat. Look for C at root. Nothing there, so create a C node. From C, look for A. Create it. From A, look for T. Create it. Mark T's is end as true because cat is a complete word. The trie now has root C-A-T. Insert car. Start at root. C exists. Move to it. A exists. Move to it. Look for R. Doesn't exist, so create it. Mark R's is end as true. Cat and car share the CA path. We only branched at the third character. Insert card. Start at root. Move through CAR. All exist. Look for D. Create it. Mark D's is end as true. R keeps its flag from car, so both car and card are stored. Now search car. Start at root. Move through CAR. All characters consumed. Check R's is end. True, so return true. Search CA. Move through C, then A. All characters consumed. Check A's is end. False, because CA was never inserted as a complete word. Return false. Starts with CA. Move through C, then A. The path exists, and that's all we need. We skip isEnd because we only care that some word has this prefix. Return true. Search cab. Move through C, then A. Look for B. No child there, so no word begins with cab. Return false immediately. Time complexity is big O of M for all 3 operations where M is the word length. Each character needs 1 array lookup at constant cost. Space is big O of n times m in the worst case. Shared prefixes reduce this significantly in practice. Here's the full code. Found this useful? Master key interview patterns at AlgoMonster and land your dream job.